Okay, so 150, this is our last section in Earth science. Okay, everybody's ready?
Yep.
Ready, set, go.
Have you ever dropped a hard-boiled egg? If so, you may have noticed that the eggshell cracked in an irregular pattern of pieces. Earth's lithosphere, its solid outer shell, is not run on a broken leg. It is more like that cracked eggshell. It's broken into pieces separated by giant cracks. A Canadian scientist, J. Tuzo Wilson, observed that there are cracks in the continents similar to those on the ocean floor. In 1965, Wilson proposed a new way of looking at these cracks. According to Wilson, the lithosphere is broken into separate sections called plates. The plates fit together along cracks in the lithosphere. As shown in Figure 22, the plates carry the continents or parts of the ocean floor, or both. Wilson combined what geologists knew about seafloor spreading, Earth's plates, and continental drift into a single theory. A scientific theory is a well-tested concept that explains a wide range of observations. How plates move. The theory of plate tectonics states that pieces of Earth's lithosphere are in slow, constant motion, driven by convection currents in the mantle. The theory of plate tectonics explains the formation, movement, and subduction of Earth's plates. How can Earth's plates move? What force is great enough to move the heavy continents? Geologists think that movement of convection currents in the mantle is the major force that causes plate motion. During subduction, gravity pulls one edge of a plate down into the mantle. The rest of the plate also moves. This slow movement is similar to what happens in a pot of soup when gravity causes the cooler, denser soup near the surface to sink. As the plates move, they collide, pull apart, or grind past each other, producing spectacular changes in Earth's surface. These changes include volcanoes, mountain ranges, and deep ocean trenches. Plate boundaries. The edges of Earth's plates meet at plate boundaries. Plate boundaries extend deep into the lithosphere. Faults, breaks in Earth's crust where rocks have slipped past each other, form along these boundaries. As shown in Figure 23, there are three kinds of plate boundaries: divergent boundaries, convergent boundaries, and transform boundaries. A different type of plate movement occurs along each type of boundary. Scientists have used instruments on satellites to measure plate motion very precisely. The plates move at an amazingly slow rate, from about 1 to 24 centimeters per year. The North American and Eurasian plates are moving apart at a rate of 2.5 centimeters per year. That's about as fast as your fingernails grow. This may not seem like much, but these plates have been moving apart for tens of millions of years. Divergent boundaries. The place where two plates move apart, or diverge, is called a divergent boundary. Most divergent boundaries occur along the mid-ocean ridges, where seafloor spreading occurs. Divergent boundaries also occur on land. When a divergent boundary develops on land, two of Earth's plates slide apart. A deep valley called a rift valley forms along the divergent boundary. For example, the Great Rift Valley in East Africa marks a deep crack in the African continent. Convergent boundaries. The place where two plates come together, or converge, is called a convergent boundary. When two plates converge, the result is called a collision. When two plates collide, the density of the plates determines which one comes out on top. Oceanic denser as it spreads away from the mid-ocean ridge. Where two plates carrying oceanic crust meet at a trench, the plate that is more dense sinks under the other plate. Sometimes a plate carrying oceanic crust collides with a plate carrying continental crust. Oceanic crust is more dense than continental crust. The less dense continental crust can't sink under the more dense oceanic crust. Instead, subduction occurs as the oceanic plate sinks beneath the continental plate. When two plates carrying continental crust collide, subduction does not take place. Neither piece of crust is dense enough to sink very far into the mantle. Instead, the collision squeezes the crust into mighty mountain ranges. Transform boundaries. A transform boundary is a place where two plates slip past each other, moving in opposite directions. Earthquakes often occur along transform